This is sections 2.2, finding limits graphically and numerically. So in the first sections of calculus, we learn the concepts of limits. If you look at these two functions and see the difference, what you should notice is for the two functions f x is rational functions and that is linear functions. Now, if you do g of 1, g of 2, g of 3, basically you want to plug this number in the function g, and you should get, I think you should get 3 for that one. Let me see here. And, right, so when you plug 1 in, you got 3, right? So you should have and g of 1 here, you got 3, g of 2 here, you got 4, g of 3 here, you got 5 as an output. When you plug in into the function f in part B, skip the math, the arithmetics there, but you should get 3 here, and plug 3 and you should get 5. The difference is at 2, when you plug 2 in, you have 2 minus 2, 0, and you divide by 0. So at f of 2 here, this is undefined. Now, besides the values at 2, when you plug in values into both functions, they are the same. So what I'm trying to say is the two functions are almost the same except at 2. So we're going to investigate what happened closely to the function at 2 by using the tables here, right? So from our conclusions, so this is what we have. F of 2 is defined, g of 2 is 4. So what happened to these two functions when x is very close to 2? Okay, so when I start the table with 1, 1.5, 1.9, notice that I choose the numbers getting closer and closer to 2's on the left, and then values that is getting closer and closer to 2's on the right, right? So then you plug into the function f and function g, and these are what we got. Okay, so they actually happen to be the same. Okay, it happened to be the same. So now what we can see is what I see on the left. You see this number getting closer and closer to what? A 4. And same thing from the right, it's getting closer and closer to 4. Since both sides, the value is getting closer and closer to 4, we say f of x and g of x in this case approach 4 from both sides as x gets closer and closer to 2 from both sides. And then we have the new notations. We write limit f of x equals 4, x approaches 2, which means this statement up here, okay? When x approaches 2, the functions approaches 4 from both sides. And same thing for g of x. Okay? Now, that leads to the following definitions. If f of x approaches b and x approaches a from both sides, we will write limit lim x arrow a beneath the lim and f of x equal b. And the number, the answer b or number it's approaching is called the limits of the functions f of x as x approaches a. So think of the limit as just kind of your targets or the things that you are getting toward, okay, getting closer and closer, okay? We also write limits of x approach a with the minus signs in the upper right corner of the number a to mean the function f of x approaches b as x approaches a from the left. So notice that if we want to consider one side from the left, we put the minus sign there. and then we have the plus to mean the approaching the x approaching a from the right hand side. Okay, so this is called the uh, one-handed limit. Okay, one-sided limit. Here's some remark. Now, not all the problems that you've seen when you let x approach a number, like in a table that you've seen here, it's getting closer, obviously getting closer and closer to a number, and that number is called the limit. Sometimes you won't see that happens. If you don't see that behavior, then the limit does not exist, abbreviated DNE. Okay, um, or a second remark here is if this limit, okay, if I'll say if f of a is undefined, the limit still exists. Okay, so look at the example that we did. If you plug 2 into the function is undefined, okay, there's no values, function values at 2. Okay, so in the example we explore, however, the limit is 4. So the limits and the function value are two different things. So this is exactly what happened at 2, a general. Then this one just saying what is behavior from both sides of the number a when x approach a. Okay. Another case when you have a non-existence of a limit is the left-hand limit not equal to the right-hand limit, right? So that's left hand, that's right hand. Then the limit doesn't exist. That means when you construct the tables, and like we did in example 1, and you see that the left-hand side, so we're getting closer and closer to a number, and then the right-hand side, you're getting closer and closer to a different number. In the left-hand, right-hand limit not the same, then the limit does not exist. Notice that the definition we have here is the limits by saying x approaching a number, the function value is approaching that limit. That definition is not a precise definition because the word approach actually is very vague. Okay, and you're gonna see again from the table point of view, sometimes it's very misleading. You think it's approaching 4, but in fact it's not approaching 4. So the first approach that we do by constructing table, this is the numerical approach, help you see the definitions and see the concept, yet not a good method, nor is it a good definition. Okay, the precise definition is actually very complicated, and I did not cover these sections. If you read the book, it's actually in these sections, right? Now, so here's some examples that you can try using your calculator. You should have a graphing calculators and try to construct the table that we did on both sides and see where it's approaching. Okay, so I'll give you the answers as you do this on your own. So here the limit is right. So limits of side of x over x at x approach 0 turn out to be 1. It's 1. And that one is turn out, it's a very special numbers, by the way. If you do using the tables, you're gonna see it's getting closer and closer to 2.71828. It's actually, it's a special constant called E. It's a natural number. That one here, your answer should be 0. Okay. And then the limit for that one are 3 over x, and x approaches 0. This one does not exist. You should see that the function does not approach anything. And that one is also does not exist. For this example, I'm going to give you the hint here. When you construct the tables, you will need to find put a 1 here, since the 0 is to 2. Right, so since x approach 1 from both sides at 1, you will need to pick the values on the left and on the right of 1. It's getting very close. So say here, see this? Getting closer and closer to 1 from the left, and you pick the values getting closer and closer to 1 on the right? So what is the value? So it's going to be something like 0.6, right? And then that might be 0.3, and then might be 0.2, and then 0.1. Now on the other side, you should have something like 1.5, 1.2, 1.1, or 1.01. So those are the values in the table. And then when you plug in, you should see that it's actually from the left side of 1, right? So when you plug in this value, you see that's getting closer and closer. In fact, I think it's going to be -1 on the left. And then you see it's actually approach 1 on the right. The left and right does not match, and so the answer does not exist, right? Now the next slide we talk about. I have the answer for these three. Now notice that these are very special limits, so that means it's very important, and so we're gonna need to memorize these three facts. The limits of all three. Notice that x all approach to 0. We got 1, e, and 0 respectively. And we're going to use this information to find the limits of more complicated functions. Now, from the graph point of view, this is what you're going to see. If you have x approaching a, see, you see that this one getting closer and closer to this values L, and then the blue on the right is getting closer and closer to the same spot, which is L. So this is the case where the functions of limits equal to L, f of a is defined. That means at a, the function value is also L. Right? So now this is the case where you see the limit is still the same. Both sides approach the same values. Approaching this spot, it's L. So the limit is still the same. However, the function values at a is undefined because a is nothing. This is the open circle. So that means there's a hole there. So at a, the function is undefined, yet the limit still equal L because they are approaching L from both sides. Here's an example where the limit doesn't exist. Notice that when x approach a from the left, you see the green dot here, it's really getting closer and closer to this point, which I call L2. And then from the right, it's approaching this point, it's called L1. And these are two different values, so the limit here does not exist. Right, so the right-hand limits approach L1 and the left-hand limits approach L2. Since they're not the same, this limit does not exist. Okay. Now let's look at quickly find the limits of the following functions. This is called graphical approach. I give you the graph and you figure out the limit when x approaching in numbers. For example, when x approaches 0, then what is the limit? Right. So from the left, you see from the left of this is 0, right? The left is 0. You see they're getting closer and closer and closer and closer to this spot, which is 2. And on the right of 0 is getting closer and closer and closer to the same spot. So limit of f of x approach 0 is 2. Okay. Now, what is f of 0? F of 0 means what's the function values when x is 0. So when x is 0, look up is the point of the graph, the y values is 2. So the limit, the functions at 0 is 2. Now, what happens with limits of the function when x approach 3? Now, when x approaches 3 from left and right, you see that it's getting closer and closer to this spot. Here is 2. And from the right, it's getting to the same spot is 2. Thus, the limit is still 2. Now, the difference is f of 3. When you look at the functions at 3, there's no function values at 3, so it's undefined. Okay. So limit exists, function at 3 is undefined. All right, so let's look at that one. What's the limits of the functions h of x, x approach -5, -5 somewhere over here, right? So coming from the left and from the right, you can see it's approached the same spot. That would give you a -1 as a corresponding y. So the limit is -1 as x approach -5. And what's h of -5? Well, the function values here is still -1. If x approach 0, okay, approach 0 is 0 in the middle. Then the left-hand side is getting closer and closer and closer to -1, but the right-hand side getting closer and closer and closer to +1. So the left-hand limit -1, right-hand limit +1, so the limit does not exist. And finally, what's h of 0? H of 0 means the corresponding y values of functions at 0. Right, so at 0, the corresponding y, you see this dot here is the point, so the corresponding y is -1 still. This is another example. What's the limit of the function g of x at x approach 0? Here is 0. Getting closer and closer to approach, this value is 1. Okay. What g of 0? Well, the same thing. This y value, the function at 0, it is still 1. And what's the limits of g of x where x approach 4? Right, so approach 4, notice that here is 4, right? So from the left of 4, you see the graph getting closer and closer and closer and closer and closer to the hole. Then the corresponding y is -2. From the right, it's also getting closer and closer and closer to this point. It also has values -2. Therefore, the left hand, the right hand limit agree, and it's equal to -2. Once I do g of 4, this is the corresponding g value. So when x equals 4, what's corresponding y? You see that 4 here, the function value is at this point. It is 1. Right? Right, so you might want to pause the video if you want to go through some of these example again. I think I'm done really fast. But the rest I'll just let you read it. Okay, so this is just a supplement video lectures that I have created sometime, right, to help you with the transitions into the online and trying to do everything on your own. Okay.